Well, okay, Bismillahirrahmanirrahim. Let's continue our discussion. In this video, we are going to talk about the Archimedes Principle, ya, and also buoyancy. Ya, jadi di video ini ya kita akan membahas prinsip Archimedes dan keterapungan ya. Jadi buoyancy itu artinya sesuatu yang mengapung gitu ya, atau terapung atau mengapung ya, intinya seperti itu. Oke. Okay, so this one ya, Archimedes Principle. Okay, so let's talk about the application of this Archimedes Principle ya. Let's say you have a rock ya, jadi batu gitu ya. You have a rock with any size ya. Jadi ukurannya bermacam-macam gitu ya. Whether small rock or the big one, yeah. And then you throw the rock into an ocean, into the sea, yeah, or into a bucket of water, yeah. Jadi batunya dilempar ya ke laut atau ke sungai atau ke ember yang ada airnya, terserah gitu ya. And you can see that the rock is sinking, ya. Jadi batunya itu tenggelam ya, mau kerikil mau batu kali kecil yang besar itu tenggelam ya. Okay. But ya, whenever we see a ship ya, and we already know that the ship a ship is made of steel ya, but it can keep its position on the surface of water ya. Jadi kalau kita lihat kapal ya yang terbuat dari baja yang seharusnya tenggelam tapi ternyata dibuat dengan sedemikian rupa ternyata bisa mengapung ya, di permukaan air ya. So this kind of concept can be understood by using the understanding of Archimedes Principle. So in this principle, we can explain. We can explain why rock, or just steel, is sinking when you throw it into the water. But when we design it, into a ship, it can be on the surface of the water. Okay, so in this video we are going to discuss about Archimedes Principle. But in this video we are going to be basic first, because Alhamdulillah, because the more complex understanding of Archimedes Principle will be taught to you, will be explained to you on the next semester when you take course of dynamics and also mechanics of fluid ya. Jadi yang ini kita hanya dasar, tapi untuk pendalamannya nanti ada di mata kuliah mekanika dan dinamika fluida ya. But the course is not in this semester ya, so you have to continue ya. If you want to know about if you want to know more about the application of Archimedes Principle ya. Okay. Let's say it's a swimming pool. Let's say this one is a swimming pool. Okay, so this one is swimming pool. Let's say swimming pool. Atau kolam renang. And then this is the water. Okay. And then there is a person here. Okay, there is a person, and he is waking himself. Yeah, and on the weight scale, yeah, he finds that his body weight is, let's say, 70 Newton. Ya, jadi ada orang dia apa namanya menimbang dirinya dan menemukan bahwa berat badannya adalah 70 Newton, ya. And then after he find his body weight, yeah, and the value is 70 Newton, he put himself into the water. Yeah, so he put himself into the water, and also the weight scale. Yeah, and so the weight scale is also put in the water. Yeah? So let's say the weight scale is a very good weight scale. Yeah, so it can be used also in the water. Yeah. So this one is the scale, yeah, and then the people is here, and he finds that the body weight is not 70 Newton anymore, yeah, but it reduced into, let's say, yeah, 60 Newton, yeah, 60 Newton, yeah, and I think it also happened to you, yeah, when you, let's say, you want to, you feel like an object is lighter, yeah, when you lift up it in the water, yeah, compared to when you lift it up not in the water, ya. I mean in the normal condition, ya. Jadi kadang juga kita merasa bahwa sesuatu itu lebih ringan, ya, ketika kita mengangkatnya di dalam air, ya, atau di dalam fluida, ya, atau di dalam air atau di dalam fluida, ketimbang kita mengangkatnya di kondisi yang normal, ya. Okay, so what happens actually? Yeah, so what happened actually? So actually there is something called with buoyancy force. Yeah. Buoyancy force. Yeah. Or in the book, yeah, in the book that I give to you, yeah, it is written with FP, yeah, force of buoyancy, yeah. In bahasa Indonesia, yeah, it is called with gaya apung, yeah, gaya apung. Okay, yeah. So let's say real way. So real way, we call it with FG. It is the real way, yeah. So the FG of the person, yeah, is 70 Newton, yeah. And then this is the way of the way of the people. I mean the way of the person in the water. Yeah, let's say it is WF. Yeah. So the WF is 60 Newton. Yeah. So the FG, yeah, or the buoyancy force is 10 Newton. Yeah, because this one is FG. Yeah, let's say this one is FG. Yeah, the FG is the direction of the FG is into the center of the Earth. Yeah. So I will draw like this. So this one is FG. Yeah. This one is FG, and then oh, not the FG. It must be FP. Yeah, I'm sorry. This one is FP. Yeah, and then the FG is like this. Yeah, the FP is 10 Newton, and then the real weight of the people is 70 Newton. So the weight of the people and the weight of the person in the water is just 60 Newton. Yeah. So let's say in this one. Yeah. So this one is, yeah. Okay, I will make it longer. Yeah. So the blue one is the WF, yeah, which is just 60 Newton. Yeah, so this one is the real one, 70, but the fluid gives something called buoyancy force. Yeah. And the value is 10. Yeah, so 70 minus 10. So the weight of the person in the water is just 60, yeah, because 70 minus 10. Yeah, so this one is 60. Yeah. So this is the principle of Archimedes. Yeah, so in the principle of Archimedes, it says that whenever you put yourself or an object into a fluid, then the fluid will give something called buoyancy force. Yeah, so it likes so it is like the water, yeah, or the fluid, yeah, give some help for you to lift up the object. Ya, jadi seolah-olah seperti fluidanya itu memberikan gaya bantuan, ya, untuk kita mengangkat benda tersebut, ya. And the force of buoyancy or the buoyancy force can be different for every fluid. Ya, jadi berbeda fluidanya, maka gaya angkatnya akan berbeda juga, ya. Jadi misalnya tadi orang ini menimbang dirinya di dalam air. Nah, itu akan berbeda ketika misalnya dia menimbang dirinya dalam alkohol, ya. Kalau memungkinkan gitu, ya. Tapi dia akan mengalami gaya apung yang berbeda, ya. So in every different fluid, ya, the buoyancy force will be also different. Yeah. Okay. Okay, now let's take a look from the different perspective of Archimedes principle. Yeah. So this one is based on our real life experience. Yeah. Okay. Now let's how we try to find the force of buoyancy, yeah, or buoyancy force, but in the scale of lab, in the scale of lab, in the scale of laboratory. Ya, jadi kalau yang tadi ini kan dalam keseharian kita, ya, skalanya dia besar, ya, karena kita harus menggunakan kolam renang, kemudian kita juga menggunakan orang, ya, atau diri kita sebagai objek penelitian. But now let's try to make it into the smaller one, so we put it into scale of lab. Ya, jadi kita coba untuk membawanya dalam skala laboratorium, begitu ya. Oke. There is a tools called, I don't know how to say it in English, ya, but in bahasa Indonesia it is, nah, something like this, ya. Okay, I don't know how to find this, to find the term in English, ya. Yeah, spring balance, yeah. I don't know it is the correct translation of this one, yeah. I don't know, but the tools is like this, yeah. Okay. Nah, so there is a scale here, number here, and then you put this one into a firm position, yeah, and then the object that you want to scale, yeah, you put it in this position, ya. Jadi yang bagian atas ini digantung, ya, diangkat bisa dengan menggunakan tangan atau digantung di sesuatu yang kuat. Kemudian benda yang akan diukur, ya, itu digantung di bagian sini. Okay, so when an object put in this position, yeah, in this point, I mean, and then you put or grab your you can use your hand to grab this point, yeah, and the scale, yeah, will be stretched, ya. Jadi skalanya ini akan tertarik, and then we'll find how much the weight of the object, ya. Jadi kan ini kelihatan berat dari objeknya itu, ya. Oke. Okay. Yeah, so something like this, ya. So I think in a laboratory work, ya, in the laboratory work of physics ya, you will find this project ya. Jadi di bagian apa praktikum fisika nanti akan ada percobaan seperti ini. Okay, so let's say this one is the tools, yeah. This one is the tool, so I will make it like this. Yeah, so simply the tool is like this, yeah. Okay, so let's say I scale an object, yeah. I scale an object here, so I put the object. So let's say I will make it into red box, yeah. So the box, yeah. Okay, and okay. And the tool show us the value of the weight of this object is let's say 20 Newton. Yeah, let's say 20 Newton. Yeah. Okay, so the weight of let's say this is the box A. So box A. Box A. Okay. So the weight of the box A is 20 Newton. Yeah. And this is the real weight. Yeah. So I also put the value of Ft, which is the real weight, is 20 Newton. Yeah. Nah, let's say I have a bucket of water. Yeah. And on the bucket, there is a scale. Yeah. And then I put water into this bucket until, let's say, this volume, yeah, and the volume is 100 centimeter cube, yeah, or 100 cc, yeah. Okay, and then I put the box, yeah. So I release the box from the tool, ya. Jadi alatnya apa? Jadi kotak atau boxnya ini dilepas ya dari neraca pegas ini, and then I put the box into the water, ya. Okay, so this one is the okay. Yeah, and because I put the water into, I put the box into the water, so this one is the box A. Yeah. So let's say the 100. So this point is 100 centimeter cube, and because we put the box into the water, yeah, so the water will, so the surface of the water will raise, yeah, let's say into this point, yeah. Okay. And now the question is, how much, yeah. Okay. And now the question is, how much the weight, how much the F ya. Oke, jadi pertanyaannya adalah berapa gaya apungnya? So how much the FP ya, the force, the buoyancy force ya. Oke. Okay, so let's say we don't have anything to scale or to find the force of buoyancy. Yeah, let's say we don't have any buoyancy force. I mean, we don't have any tool to find the buoyancy force. Yeah. Okay, so what can we do? Ya, jadi apa yang harus kita lakukan kalau kita ingin tahu FB ya, tapi yang diketahui hanya berat asli ya dan volume yang tadi bertambah gitu ya, airnya dari 100 cc ke 150 cc. So what can we do? Yeah. So we can just find the way of so the FP will equal will be equal with will be equal to way of 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 the water of the weight of the replace water, yeah, not replace actually. So wait a minute, try to find okay, the weight of the moved water, yeah. Okay, see the moved, yeah. I'm sorry if I use wrong term, yeah, to describe the situation, yeah, but actually the on the first condition, yeah, the volume of the surface of the water, yeah, is on this one, yeah, in this point, yeah, the surface of the water is on the 100 centimeter cube, yeah, but yeah, after I put the box into the water, the surface of the water is raised, yeah, is raised, and it reached, let's say, 150 centimeter cube, yeah. So there is a change of the water from this point, yeah, into this point, yeah. So we are going to find, yeah, the weight of this water, yeah, and the weight of this water is similar to the value of buoyancy force, ya. Jadi berat daripada air yang terdesak atau air yang meningkat itu ya, dari yang tadi cuman 100 menjadi 150, itu kalau kita hitung beratnya ya, maka kita bisa tahu gaya apung ya. Jadi gaya apung itu sama dengan berat daripada air yang terdesak ini. Okay. And if we want to find the weight of the water, is W equals to mg, yeah, and this one is m fluid times by g, yeah. And if we want to find the mass of the fluid, so we can use density formula. So rho of the fluid equals to m fluid divided by the volume of the fluid, yeah. So m fluid equals to rho fluid times by V fluid. Okay, so I will make it into the next. Okay, W of fluid equals to mass of fluid times G, yeah. And then M fluid equals to rho, or the density of fluid, times by volume of fluid, ya. Okay. Now we are going to find the volume, the mass on the fluid first, yeah. So let's say we use water here, yeah. So the fluid that we use in this project is water, yeah. And the fluid, the density of the water is 100 kilogram per meter cube, yeah. Okay. 100 kilogram per meter cube, ya, and then times the volume of the fluid, ya. So the volume of the fluid, ya, I mean the move fluid, ya, is 150, ya, minus 100, ya. So it is 50 centimeter cube, ya. But this one is still in centimeter cube, yeah. So we have to convert it into meter cube, yeah. So it will be 5 times 10 minus 5 meter cube, ya. Okay. Okay, so 5 times 10 minus 5, yeah. 5, yeah. 5 times 10 minus 5. 5 times 10 minus 5, yeah. So this one is the volume of the moved fluid, yeah, or the raised fluid, yeah. Okay, so 5 times 10 to the power of minus 5, yeah. So this one is 10 to the power of 3 times 5 times 10 to the power of minus 5. Yeah, so the result is 5 times 10 to the power of 2. Yeah, so this one is the mass of the raised fluid. Yeah, 5 times 10 to the power of 2 kilogram. Yeah, okay. Now we are going to find the weight of the fluid. Yeah, weight of the fluid is mass of the fluid times by G. Yeah, M of the fluid is 5 times 10 to the power of minus 2 times G. Yeah, in this case, let's say the gravitational acceleration is 10 meter per second square. Yeah, so we put 10 here. Okay, so 10 5. So the result, yeah, of this calculation is 10 to the power of minus 1. Yeah. Okay. So this one is the weight of the fluid. Yeah. And because, yeah, the weight of the fluid and the weight of the moved water, I mean the weight of the moved fluid is equals to the force of buoyancy. Yeah. So it's also the value of the buoyancy force. Yeah. Nah, jadi ini adalah gaya angkatnya. Ya, jadi so this one is the buoyancy force. So the buoyancy force is similar to the weight of the raised fluid. Yeah. Okay. So if we make a conclusion here, so the real weight of the box is 20 Newton. Yeah. So the Fg is 20 Newton, and then the buoyancy, yeah, the buoyancy force is 5 times 10 to the power of minus 1 Newton, or 0.5 Newton. Yeah. So the weight of the box in the water is Fg minus Fp. Yeah. The Fg is 20 minus 0.5. Yeah. Okay. So the weight of the box, yeah, the weight of the box, yeah, inside the water, yeah, if we scale it, ya. Jadi kalau kita menimbang atau ingin mengangkat box A ini di dalam air, ya, maka kita akan merasakan beratnya hanya 19,5 Newton. Ya. So when we try to lift up the box inside the water, it feels lighter, because the weight is only 19.5 Newton. Ya, jadi kita akan merasa agak ringan karena yang tadinya 20 Newton ketika kita angkat di dalam air, dia itu seolah-olah seperti 19,5. Ya, jadi ya berkurang tapi kan lebih lebih ringan, ya, seperti itu. And this concept is used to explain why why a ship can float, meanwhile small rock is sinking into the water, into the deep of the water, because the designer of the ship, the designer of the ship recognize this principle. So the designer designs the ship so it can be lighter, it can be lighter and it can move up. I mean, it can float on the surface of the water. Okay, so I think this is very simple, but it can be really helpful for humankind. Yeah. Okay, so the video is finished for the Archimedes. So after this, we are going to so we are going to after this, after on the next video, we are going to talk about the conservation of mass. Yeah. Okay, thanks for your attention. Until this video, and let's meet up again on the next video. Thank you.